Hey everybody, this is Matt with mathsmath.com. Thanks for joining us here today as we talk about equations, how we write and graph equations. We're in the Common Core standard of functions, and we're going to be defining, evaluating, and comparing functions today, especially writing them and graphing them. Our guiding question is, how do we write and graph equations? It's pretty simple. You'll be able to answer this by the end of the lesson today. So let's get to it. When we think about an equation, we have x and y, and how we write it, we're usually given a word problem or something, and we're going to talk about it and figure out how do we actually solve it. Here's a dad and his kid on the beach, namely me and my son, and we were running down this beach, and you know what? My son lost his hat on the beach, and we had to go for miles up and down this beach trying to find his hat because we had walked up and down to the nearest pier. Well, when you look at this graph here, what does it mean? You got a graph with miles in the y-axis, and the x-axis is time for hours. What does it mean? Okay, if you think about it, we talk about losing a hat. This could be 3 miles away from the hat at 0 hours. Then at 1 hour, we were 2 miles away, and at 2 hours we were 1 mile away, and at 3 hours we were 0 miles away from that hat. Does that make sense? This is the idea there. As time progressed, our distance to the hat decreased. That's what that graph can tell us, having to do with miles and hours. Many other things that we can look at too. So let's talk about how we write an equation. When we look for pattern in numbers, we can write an equation based on the given information, say in a table. So we can find a pattern, and let's do it. Here it is. Notice that I'm going up 1 first here, up 1, up 1, up 1. And notice what happens now. In the y values, I'm also going up 1, up 1, up 1, and up 1. So that's our pattern. As I go up 1 in the x, I go up 1 in the y. All right? So what's the equation for this set of numbers? How do we write an equation given this table of data? How do you think we do that? Well, like I said, we go up 1 here in the x and all the way across, and then we're also going up 1 here through all of the y's. How do we do that? Well, as we look at it, if you think about it, you don't have to really think about it, it's right there. Think about it. As x goes up 1, y goes up 1. Well, as x is at 0, y is negative 4. So think about the equation here. If this is 0, what's left has to be negative 4, right? What's left has to be negative 4, because when I plug in 0 there, I get negative 4. So really all that leaves me to is, what is x, and is there any numbers in front of x? Right? So if I plug in 0 for x, I get negative 4. If I plug in 1 for x, I get negative 3. Well, then just solve it. What is 1 minus 3? That's negative 3. So you just put 1x there, and you're good to go. So here's your equation for that set of data. All right? And the biggest thing is you just got to test it. Plug in the x value, see if the y value spits out. Just like we plugged in 1, and it spit out negative 3. If we plug in 2, it spits out negative 2, and so forth. Just make sure it works. Plug in negative 5, or plug in negative 1 rather, it spits out negative 5. Plug in positive 2, and it spits out negative 2. And these are points on a graph. So just because we're talking about how we write an equation doesn't mean we stop and say we don't graph it. Here is a point on that line. Here is another point. And if we plot those 2 points and connect the dots, we'll have the line for this graph. All right, why don't you try this one? What's the equation for this set of numbers? You're going up 1. How much are you going up here? Remember, you always want to check out and see where x equals 0 and see what spits out for y, because that's what's tacked on at the end of the equation there. And then if you notice, the distance here between 3 and 7, 7, 11, 11 and 15, that number goes in front of the x. Like this. When x is 0, this number's tacked on the end, and the difference, as long as it stays the same, 3 up to 7 is 4, 7 to 11 is 4, 11 to 15 is 4, that 4 notice is right in front there. Right? It's no difference if it's in ordered pairs too. So if I have 0, -1, bam, this is x then y. If I have 1, 3, this is my next ordered pair. So it's no different if it's in a table or if it's in ordered pairs like this, okay? Don't be afraid to get it and put these in a table if you need to, or just use them like that, okay? All right, well, let's talk about what an independent variable is. This is something you might hear occasionally in math, especially dealing with functions in the domain and range. Well, the independent variable is the variable that's not affected by the other one. It's usually the x or the domain. Okay? It's the x or the domain. It's the independent variable and it's not affected by the other variable, the y. Just like the input, you put in the x value, what spits out? The y. So you get to choose the x value. Just like here, number of hours traveled, and the number of hours and the number of miles traveled. So at 0 hours, you're a mile away from where you wanted to start. At 1, you're 3 miles past it, 2, 7 miles, 3, 11 miles, 4, 5 miles. Okay, at 4 hours, you're 15 miles past it. So this x, the domain, is the independent variable because you put the 0 in the equation and it spits out the -1. You put the 1 in the equation and it spits out the 3. These guys down here are dependent upon the x. So hint, hint, they are called the dependent variable. The dependent variable is the variable that is affected by the other, and it's usually the y or the range. No big deal there. Okay, so it's usually the y. All right, x here is the number of days, y is the number of planes flying. Well, at 0 days, we have 1 plane down. 1 plane down and out. It's not working, so we have a -1 amount of planes. Well, on the first day, we have 3 planes flying. On 2 days, we have 7 planes flying. 3 days, 11 planes, and so forth. So here, again, this is the independent variable. We take the number here, plug it in the equation, and we get the y. These are the independent numbers. The independent variables comes from the y there. Does that make sense? The y depends on the x. That's pretty much it. All right, so let's talk about graphing an equation. My recommendation for graphing an equation is you just pick 3 numbers. That's the x. It's independent of what spits out. So usually I like to pick -1, 0, and 1, and then I plug them into the domain. Plug them in as the domain and see what spits out for the range, for the y values, and then connect the dots. That's the 3 simple rules. Plug in -1, plug in 0, plug in 1, see what you get, and then connect the dots with those ordered pairs because the -1 and the y value is the first point, the 0 and that y value that spits out is the second, and so forth. So let's do that with this guy. Let's graph y equals x plus 1. Let's see how we can graph it. Well, these are the 3 x values I'd like you to plug in. Plug in -1, see what spits out. Plug in 0 and 1 and see what spits out. Those now are your 3 ordered pairs that you will use to graph your equation. All right, so we're going to plug in each value for x. So plug in -1, you get 0. And we put in there, put in 0. Does that make sense? Now we're going to take 0, we got it there, plug in that x, take that y, we plug it in there, and we get 1. Y equals 1 plus 1. Again, take that 1, plug it in there, take what you get, put it in there. So these now are our 3 points. Our first point is -1, 0. Second one is 0, 1. Third one is 1, 2. We have 3 dots now that we can put on the graph. There's your first one, -1, 0. Second one is 0, 1. And your third one is 1, 2. Those are 3 ordered pairs. Now from here, you just connect the dots and extend it both above and beyond. So you connect the dots from these 3, and you want to extend it all the way through the graph. Does that make sense? Don't just stop at this dot and that dot. Connect the dots, bam, there's your line. Does that make sense? Pretty easy, huh? Not too bad. All right, let's graph this one. Y equals x squared plus 1. All right, we're going to pick those 3 points, -1, 0, and 1. Plug in each value. We get -1 times -1, which is 2. Plug in 0, 0 squared. Big fat nothing, plus 1 is 1. And then 1 times 1 is 1, plus 1 is 2. So notice we have 3 points here. Both of them, you plug in -1, you get 2, and 1, and you get 2. So we've got to plot those points now on the graph. Bam, here you go. So it looks like it's almost a V. You know, sometimes you might actually need to get more points to draw a more accurate picture. So for example, let's take -2. Well, -2 times -2 is +4 plus 1 is 5 there. So -2, 5. Let's do +2, which also gives us 5. And then we can draw the graph from here. Gives us a little bit more picture that it looks like this little horseshoe, letter U, up and down, right? So sometimes you might need to actually pick more points in order to graph it. But no big deal, right? It's not that hard to plug in those points. All right. Why don't you take a little bit, graph these two equations, plug in -1, 0, and 1. See if you need to plug in a few more points too, just in case. All right, now here, this is the absolute value of the number. So when you plug in -1, it becomes 1. So that's 1, -1, 2. Plug in 0, well, the absolute value is 0, 0. So then 0, 1, plug in 1, and you get 2. Right here, what the equations should look like, something like this. Notice in the second one, you probably needed to plug in quite a few more points to get it. It is just like that x squared plus 1, but it's more steep. All right. Have a good idea of how to write and graph equations now? Pretty simple, as we talked about just picking points and writing equations from tables. And that's it for today, as we talked about writing and graphing equations and walking on the beach. Well, this is Matt from mattsmath.com. Check us out on Facebook at Solving Math Problems, or Twitter at Matt's Math, and enjoy math and walking on the beach.